Am I audible to everyone? Can you see my screen? Yeah, so good evening to everyone. I am Yashvi Sheth, a research scholar at IIT Bombay, and I will be taking the live sessions for the course Basic Principle and Calculations in Chemical Engineering for this semester, which is instructed by Professor Subroto Majumdar from IIT Guwahati. So for this course, uh, every Tuesday there will be a live session from 6 p.m. to 8 p.m. and also the video of this live session will be uploaded on my YouTube channel for your further reference, or if in case if any of your friends or colleagues miss the video or live session. So to start with, firstly, I will be giving you the brief of the lectures that has been covered for the first week of the course. So basically, this will be my routine. Like I will be starting with the brief of the lectures, and then I will be discussing with the assignments, and later on I can take up the doubts that you have. So in the first lecture, basically it was discussed about what is chemical engineering, what is the history behind it, and what are its roles. So, if I ask you, like, what do you mean by a chemical engineering, and in future when you will be a chemical engineer in near future, so what are you going to do in any industry, or what will be your task, or what do you understand by chemical engineering? So, if any one of you would like to answer this question. So yeah, basically we chemical engineers uh, deal with the synthesis or the manufacture of any chemical or related to it. So whatever chemical or whatever material we have with us in our routine life, each and every thing is manufactured in an industry. Now in this industry there will be some physical sciences. We take the examples from it, we apply the principle of some that sciences, and later on we try to convert the raw material into its product form. Now the raw material can be in any form. There might be just some physical transformation, or there can be some chemical transformation as well. Both the things are included in the process. So at the end we get some product which is saleable in the market. Now this product needs to be low in cost. So we as chemical engineer try to optimize the process by looking into the basic science behind the process, and we try to optimize the cost of the process as well, so that it is readily available in the market and it can be used by each and every person uh, uh, very easily without bothering about its cost. So now, as you know, that chemical engineering branch is the most versatile one, where you will be able to find its application in almost each and every field. Now if you just a second. If you take the example of any industry, maybe if you like you drive vehicle, so petrol, diesel, each and every, like petrol and diesel, it is manufactured in a chemical industry, where we try to convert crude oil into its various products. Like these products can be petrol, diesel, even the aviation fuel, Apart from this is just one example. There can be many more applications, like uh, if you use water and you just discard it. Now there the discarded water from the toilets, from the gutter, whatever the wastewater is generated, that wastewater is treated in municipality, and it is for that also we chemical engineers help in designing the process and for the treatment. Apart from that, there are many there are many roles of chemical engineers in for the synthesis of semiconductors, in nanotechnology nowadays, where nanotechnology is applied in each and every field, like in the transistors and in each and everything. We try to synthesize nanoparticles and apply the nanotechnology. Then in food processing, where we try to synthesize or uh, get some processed packaged food. And in agriculture industry, where we for example, we have IFCO, we have CRIPCO in India, which synthesizes the fertilizer or urea in bulk scale. So these all are the examples where we play a major role. Now coming to the brief of second lecture. So this lecture deals with many definitions, which as a chemical engineering are very basics for you to remember and for you to understand. So now what do you mean by a process? So can anyone tell me what a process means? Okay. So a process, it can be any process like industrial or any other process, where you try to change one form of material into another form, where it undergoes a series of operations. May it be physical transformation, or it can be chemical transformation. So we apply some external sources in the form of energy, in the form of time. We give some time for them to interact, and later we get some output product. Now this is the main target, to get the output product. Now the entire operation of converting the raw material to the final product is the process. Now it can be of two types. It can be unit operations or it can be unit process. Now unit operations are the ones in which there will be just physical transformation. Like for example, if you have a sugar syrup and you try to boil the water from it, so there will be some amount of sugar which will be solidified. Another example uh, Another example in our daily routine is when you try to boil the water at your home. Now, as the temperature increases, there will be some amount, like more and more vapors of water will be able to you will be able to see. So that transformation is the transformation of water from liquid phase to the vapor phase, and that is a physical transformation. Now such transformations are highly required in industries and are termed as unit operations. Apart from this, there will be many unit processes. So now this unit processes, what do they include? It will be chemical changes of the material that are fed to the reactors or in any uh, instrument or equipment. There will be some chemical transformation to get some profitable product. Now if you want to manufacture sugar, or you manufacture ethanol from sugar solution, or some sulfuric acid, etc., all this requires some physical chemical reaction. So this is the example of unit processes. Now for any industry to run, there will be a combination of these unit operations as well as unit processes. which will simultaneously give you the final product. Now, there can be different types of process based on the mode of operation. For example, uh, batch process. Suppose you have a reactor, so there will be inlet of raw materials, okay, and you just dump all the raw materials at a time, and now you wait for the reaction to occur. Now once the reaction, this is at, like, you allow the raw materials to enter at time t equals to 0, and you take out the product at time t equals to t. That will be the end of the process. Now, such batch operations are like very widely used in industries, but can you give me some examples of batch operation where you have seen batch mode of production? Synthesis, like usually batch mode of operation depends on the quantity of product required and also the parameters to be handled, because not all parameters can be handled in a continuous mode. So basically pharmaceutical products, drug like penicillin, so such products, dyes, and all the pharmaceutical intermediates, active pharmaceutical intermediates API, are manufactured in a batch mode, which usually depends on the demand from the market, and depending on that batches are made. Apart from that, there can be semi batch process, where you just give the input of all the materials at time t equals to 0, and you continuously draw the output. Apart from that, there can be continuous process as well, in which you continuously have some inlet and continuously have some outlet, and all the process that is going on in the reactor, it will be continuously occurring. So example of such process is production of nitric acid, sulfuric acid, production of petroleum products from crude oil, etc. So now apart from that, there can be based on the variation with time and spatial coordinates, there can be a steady state process and unsteady state process. Now, as you have looked into batch and continuous mode of processes, in continuous mode, if you see, suppose suppose you have a sorry. Suppose you have a reactor. Now, there will be some inlet, there will be some outlet. So now, as per the law of mass balance, the amount of inlet and the amount of outlet, it has to be same. Now if you, for constant level to maintain, now if there will be more amount of inlet and there will be lesser amount of outlet, then the height will increase, or vice versa. So you do not want that to occur, so this process will run in such a way that inlet and outlet will be same. So in such a case, the process variable here, that is the flow rate, remains constant, or it do not change with time. So such processes are steady state process. Now coming to this unsteady state process, where you dump all the input raw materials, and after dumping all the input raw materials, say for example it has A and B, now A and B will continuously react to give C. Now this, as the time proceeds, the conversion of A plus B to give C will increase. Okay, so as the time progress, the process variable, that is the concentration of A, B and C will change in the reactor, and hence such process is called unsteady state process, where the process variables keep on changing with time. Now apart from that, there are lumped processes, distributed process, multi-phase process, which are highly used in industries. So these are some of the common examples of important processes that I have highlighted, and major applications or major usage in industries I have highlighted. Say for example, suppose you have you want to transport a material. In any industry you need to transport like liquid from one place to another place through pipelines. So pipeline is one mode of one mode by which you can transport the material. Apart from that, there can be gases also that you need to transport, or that you need to pump. So gas also, it will catch up from one place and it will transport it to another place. So that is also done. Now apart from that, if you have solids, so solids are difficult to handle, like it is heavier also. So in that case you need some pneumatic conveyors or screw conveyors, where you will be able to transport the solid materials also. Apart from that, there will be some size reduction process, where to enhance the reaction kinetics, or suppose you have manufactured sugar and now you want to make it sellable. Now if you have sugar in some random size, so it will not catch the attention of the market. So you want some uniform size or uniform shape of those sugar. So in that case you try to make it in such a way that product is more saleable. Apart from this, there can be solid liquid separation in the form of filtration, or there can be decantation process. The most common example for decantation process is the separation of cream from milk, which is done in the industry. Now there can be a sedimentation process also, where the solid particles which are present in water, you can separate the solid particles from the wastewater stream, or suppose you have some reaction occurred, and later on it in the final form it has some amount of liquid and some amount of solid. So now you allow the solid to settle, still there will be some amount of solid that remains in the mother liquor. So you allow that solid to be separated by sedimentation process. Also you need to provide continuous mixing in any reaction or in any process to occur. So for that you usually use is impellers, propellers, etc., which provides, suppose you this is the impeller, so this will rotate axially or radially, and it can give both the types of mixing, and it will allow the liquid or any fluid like gas, usually liquid, to mix. Apart from that, there can be condensers. These condensers are more commonly connected to a distillation column, where suppose you have a vapor product and you want the product to be in liquid form. So you convert gas or vapors. No, sorry, gas is not a proper word. So you convert vapors to liquid by liquefying it or by condensing it. Another example is evaporation, which for example, if you want some there is some fruit juice and you want to concentrate it, so in that case what you do is you allow some amount of water to evaporate. So in that case what will be left is the concentrated water. Now such examples are listed here also, you can look into it. Now starting with the assignment, first question is, what is the dimension of velocity? So to know the dimension of velocity, here you have what is velocity? Distance per unit time. Now if you look at the unit, distance is measured in meters in SI per unit second, which can be written as meter per second. Now the dimensions for meter is length, and for second it is time. Okay, so the dimensions for velocity is length and time inverse. So the answer for this question is length into time inverse. Next question is which of the following equipment is not used for the crystallization? So here we have four options in which it is scrapped surface crystallizer, post circulating liquid evaporator crystallizer, circulating magma vacuum crystallizer, and drying liquid crystallizer. So do you have any idea which one of the following is not a crystallizer, or it is not used for crystallization? uh, okay. Drying liquid is the correct answer. So for I would like to tell you the just a second. I would like to tell you the mechanisms for each of the crystallizers. Here in scrapped surface crystallizer, you have suppose this is the inlet, like this will be the inlet and this will be the outlet. You allow this surface to cool down, and once this comes in the contact of this plate, due to the cooling there will be some amount of crystallization, and which is continuously scrapped. So this type of crystallizer is also continuous crystallizer, where you continuously scrap the product or the crystals. Apart from this, there is forced circulating liquid evaporator, where this is suppose the feed goes in here, like from here to this heat exchanger, where the temperature of this feed solution is increased. Now when you increase the temperature of feed solution and when it enters here, there will be some amount of liquid which gets converted into vapor, right? So as liquid transforms into vapor, the amount of liquid left in this solution will be less, and the soluble solute per unit liquid will be less. Now the solubility will be same, so in that case there will be constant increase in the concentration of soluble solid, and once this concentration is the concentration of solute is above the solubility limit, then it starts crystallizing or it starts precipitating. So this is how we crystallize in here, and we separate some amount of salt slurry. We take out some and we take out some in the, like we bypass some amount. This is how it works. Apart from that, there is one more, like circulating magma vacuum crystallizer, where similar phenomena occurs, where we have one heat exchanger, but here we have steam which heats up the feed solution, and here on the surface there will be some amount of vaporization, and this vapor, once this vaporization occurs, here the crystallization starts due to more concentration of soluble solute. So yes, the correct answer for this question is drying liquid crystallizer, as we have not seen any such crystallizer. Just a second. Uh, Next question is Grashof number is defined as dash. So the formula of Grashof number is displayed over here. Now if we so what is the significance of Grashof number? So Grashof number usually signifies the spatial variation of the fluid or the motion of fluid as the temperature varies and how much amount of motion is restricted due to the viscosity of fluid. So what it accounts for is, suppose you have a fluid in here and there you heat, there is T1, there is T2. Okay, so there will be some amount of gradient of the molecules in present here. It can go from here, like the transition, the gradient will be from this place to this place where T1 is greater than T2. So now due to this there will be molecule shifting, and due to that there will be a buoyant force created, which is represented by the delta T. Now this buoyant force will be there. Apart from that, you have some viscosity of this solution. Okay, now more the viscosity, more it will resist the flow of the fluid. So that is incorporated here. And also this represents the, like, rho square into g L cube. It represents the inertia, like there will be some amount of the need of the solution to be in its original state, right? So that is on incorporated here. Now since mu represents viscosity and it is in square, there has to be viscous force square in the denominator, and there will be buoyant force, as there will be buoyancy effect due to the temperature gradient as I mentioned here. So that force will be there and inertia force will be there. So the correct answer for this is inertia force, buoyancy force and viscous force square. According to Buckingham pi method, number of groups formed depends on number of variables and number of fundamental dimensions. Now the number of dimensionless groups that can be formed are as like it can be represented by what? So it is usually it follows the thumb rule, which is the number of dimensionless groups will be n minus j. Next is Reynolds number is equal to dash. Like you need to say the formula. So the formula is very simple. It is rho v d by mu, which is c. But can anyone tell me the significance of Reynolds number? Because this Reynolds number is the most commonly used terminology in anywhere in chemical industry, and we chemical engineers come in have to deal with Reynolds number very frequently. So can anyone tell me this? You can unmute yourself and tell me. Actually, I'm not able to see the chat box. So you can unmute and say.
Flow characteristics.
Okay, right. So can you tell me in detail, like what kind of flow pattern, like how it is related to the diameter, how it is related to the velocity, density, and viscosity?
Laminar flow, turbulent flow.
Okay.
And laminar flow, say like since d, v, rho are in the numerator.
Okay.
When the number increases means the density will increase, velocity will increase, or the diameter of the pipe. If they increase, then the turbulence will occur within the flow.
Right. Okay. So he correctly said, suppose you have a pipe, okay, and there is a, now you can unmute. Thank you. Suppose you have a fluid flowing, okay, so now this, it has some diameter d, it has some density rho, and it has some velocity v, viscosity mu. Now what Reynolds number tells is the flow patterns of the fluid. Suppose this is the fluid, this can be the flow pattern, this can be the flow pattern, okay. This flow pattern is of molecule, so interpret this flow pattern as the flow which is followed by a molecule, okay. So now if the velocity is more, then the particles have more energy, because we are supplying more amount of energy for the fluid to flow. So in such case, if the fluid flows at a faster rate, the molecules may go from here to here or in any random direction. It can strike with the wall and it can come back. So in that case, there will be a higher amount of turbulence. So Reynolds number is directly proportional to V. Similarly, if we look at the diameter, now if we increase the diameter, like lower the diameter, then the adherence of the fluid with the walls will be more. Now, and if we increase the diameter, then lesser fluid will be adhered to the walls and it will cause more turbulence. So it is also directly proportional to D. Now if we look into mu, now higher the viscosity, it will resist, like the molecules will be more compactly bind, it will the layers of the fluid are more compact, so in that case it will not allow the layers to slip, or it will not allow the flow. So in that case Reynolds number is inversely proportional to mu. So the correct relation over here is rho Vd by mu. Also, if we see, Reynolds number indicates the ratio of the inertial forces, because here uh, the fluid needs to remain in its original state, which is denoted by rho Vd, and the viscous force, which is denoted by mu. So it is ratio of inertial force to the viscous force. Okay, so here the correct answer is rho d by mu. Apart from that, there are some regimes, flow regimes, as someone correctly pointed out. It can be laminar, where Re is less than 2100. If Re is greater than 4000, the flow pattern is turbulent, and in between range, Re is said, like in this range, the flow pattern is intermediate, or transition flow pattern. So far, do you have any doubt? Anyone? Okay. So now, if not, we can proceed to the next question. How is diffusivity of gas related to the temperature? So, sorry. Suppose these are the gas molecules. Now, it is at temperature T1, and it has some amount of energy to flow in any direction, and gases has the most random motion. Now if you increase the temperature, then this amount, the energy of each and every molecule, as the temperature increases, the energy of gas molecules increases. So as a result of this, the ability to travel ability to travel by the gas molecules travel and collide with other particles, other gas molecules increases. So which means the diffusivity, which is a measure of the ability to travel from one phase to another phase, like one place to another place, it increases, and it is related by this proportion DAB. So in that case, this means that it has a direct relation. Now since gases are more randomly arranged, so temperature has more prominent effect on its motion, which is why DAB is proportional to temperature raised to 1.5. So this is the correct answer. Moving to the next question. Fixed law of diffusion is dash, where we have J, D, C and X as molar flux, diffusion, coefficient, concentration, position. So you can look into this diagram, and suppose this is Z equals to Z1, this is Z equals to Z2, and here it is C1, C2. Okay, now this is higher concentration, that is C1 is greater than C2. So since C1 is greater than C2, what type of diffusion would you expect? So diffusion will occur in the direction from higher concentration to the lower concentration, which is from here Z1 to Z2, right? So this is the direction of flux. Now so flux is related directly to the concentration gradient. Okay, now since the motion of particles is related to the distance also, for example, here there will be some concentration, and here there will be some concentration gradient. So the gradient and the distance also depends. However, more the distance, more uh, more time it will take, so it and lesser will be the flow, because there will be no direct contact. So it is inversely related to the distance. Now we go from this to this, while the distance is calculated from this, that is Z2 minus Z1. Okay, Z2 to Z1 is calculated in this direction, while the flux is in this direction due to the concentration gradient in this direction. So there has to be a negative sign to incorporate the opposite nature of the flow, that is the flux, and this quantity. Now to remove this proportionality constant, we add over here one proportionality constant, that is diffusivity, delta C by delta Z. Now if we look at very differential scale, then J will, like this delta sign can be replaced by del C by del Z, or this Z can also be in Z is one form of dimension. It can be X also, as it is represented here in the form of X. Can anyone tell me why there is partial differential and not complete differential, like dc by dz or dc by dx? Someone can unmute and tell me if they want. Anyone? So if not, we can proceed. The answer to this question is here. the partial differential comes into picture, because for now we have considered just one direction, that is z or x, right? However, the motion can be in any direction, x, y, z. So if we are considering with respect to x, then it has to be del c by del x. If it is with respect to y by del c by del y, or if it is with respect to z, del c by del z. So here we keep in mind that other two movement we are keeping constant. For example, if you have del c by del x, we ensure that the other two terms, that is with respect to y and z, they are constant. Now if we take dc by dx, then we are assuming that there is no concentration gradient in y and z direction, and that is why there is no motion due to concentration in gradient in y and z direction. So that this is the difference between del operator and that is partial differential operator here and the complete differential operator. I hope you got this point. Moving forward, SI unit of specific enthalpy is dash. So here if we look into enthalpy, then enthalpy has same units of energy, which is like the SI unit will be joules. Okay, now what does specific term represent here? So specific means, like of any quantity, specific quantity is the measure where you measure the quantity per unit mass. Okay, so here specific enthalpy would be, quantity here is enthalpy per unit mass. So if we put the units, enthalpy has SI unit of joules and the mass has SI unit of kg. So the unit of this, the answer of this question is joule per kg. I guess there is some typing mistake. It has to be joule per kg. I will correct it and upload once again. So please note it has to be joule per kg. Moving forward, here it is asked to find out the specific gravity of a fluid with 28-degree API. So here there are two terms, specific gravity and degree API. So if anyone knows what is the meaning of specific gravity and 20 degree API, they can let me know, like they can differentiate between the two. Anyone would like to answer?
Degree API is equal to 141.5 by specific gravity minus 131.5.
Yeah, so this is the formula. Now if you want to look into the significance of this terms, so degree API is used for, actually you are right, so this is the formula as you mentioned. Now if you want to look into the significance, so specific gravity is the measure of density of any fluid with respect to the density of water. Now here we use water because it is the universal solvent and water is the most commonly used solvent, so it is very easy to measure. Now there are many petroleum products also. So if you there is a special term which is API. Actually I forgot the full form. It is American Petroleum Index or so. You can look into it later, but it is the measure of the density of the petroleum product with respect to density of water. So this is the relation. Now, since both are the measure of density with respect to water, there is one correlation to correlate API, like degree API, with specific gravity, which is related to this. Now, if you put all the values of degree API in this, you will be able to calculate specific gravity. Can someone calculate and tell me the answer? You just need to put up the formulas, values in the formula. Yeah, so someone has mentioned in the chat box option C, which is the correct answer. So, for conversion of or for relating any density in the form of API to specific gravity, you can use this formula and you can relate. Moving forward, here there is a question where for a gas liquid mixture, the volume fraction of gas is 0.6 and the volume fraction of liquid we need to calculate. So, what this is a very basic question actually. So, for any mixture, the suppose it is a closed system, gas plus liquid, so the total fraction is always equals to 1, right? So here we just have gas plus liquid. Now to consider volume fraction of gas plus volume fraction of liquid, since we just have two components in here, so volume fraction of gas and volume fraction of liquid, the summation of both should be equals to 1, right? So we have alpha g here. Now if we put up that value, alpha L equals to, that is the volume fraction of liquid, is equals to 1 minus 0.6, that is equals to 0.4. So 0.4 is the correct answer here. So now so far, do you have any doubt, anyone? If anyone has doubt, they can unmute and tell the doubt. Okay, if not, we can move to week 1 assignment. So the question here is, what is the example of a batch process? So if we look into the options, the separation of petroleum products from crude oil, this is usually occurring in atmospheric distillation unit, which is known as ADU, and in combination with VDU, that is vacuum distillation unit, where we fractionate oil, okay, into its components. It can be ADU, VDU, and depending on what products we need, we use a series of both. We get diesel, petrol, aviation fuel, coal tar, etc. So this process is a distillation process which is continuously carried out. So this is not the correct option. Apart from that, there is blending of two polymeric solution in gently in a tank. So this also it is continuously done. Now dairy process, depending on the requirement, it is done in batch mode. So this is the correct answer for this question, which is dairy processing. Moving forward to the next question. Here it is very basic actually. It is asked like if we have change in the variables such as pressure, temperature, flow rate, volume with time, then what is the type of this process? So the type of this process is unsteady state, because in unsteady state process, as I mentioned earlier, there will be change in the process parameters here, pressure, temperature, flow rate, etc., with respect to time. So this is the basic definition that you should remember. Next question is, variables associated with distributed process can change with respect to time but not with spatial variable, spatial coordinates xyz. So can someone here elaborate or tell
The
me
answer is
the distributed process?
the answer is false.
Yeah, so
The
can you
meaning
tell
of
me
the
the
distributed
definition of distributed process?
the distributed process means in different directions, x, y, z. They are distributed. So spatial coordinates will definitely be there in distributed processes.
Okay, yeah, that is the correct answer. So in distributed process, there will be change in both time and x, y, z. That is spatial coordinate and time. So correct, like here the answer is false. Next question is, based on multi-phase contact, select the correct phase of contact for fluidization process. Now for that, for this question to answer, you need to understand what is the fluidization process. So fluidization process is the process, suppose like you can see the picture here, you allow the gas or liquid, like since it is a fluidization, like fluid can be anything, gas also or liquid also, both the terms or both the states of matter are fluid. So any fluid, may it be gas or liquid, if you allow it to pass from the solids, now at some velocity of gas and liquid, all the solids will be settled, they will be very close to each other. Now as you keep on increasing the solid, gas or liquid velocity, here there will be various types of force acting on the solid particles. So suppose if you take a look on a solid particle, there will be a drag due to the motion of fluid in the upward direction, which will try to lift the particle, and there will be gravitational force mg due to the particle weight. Now initially when we have low velocity, the drag will be lesser than mg, so particle will be in stagnant motion, like it will be settled. Now if you keep on increasing the velocity, there will be some point where drag will be equals to mg, so particle will be in steady state position. Now there will be one moment where drag will be greater than the weight of the particle when you keep on increasing the velocity. So in that case, the particles will be lifted up by the gas or the liquid which is present. So in that case, the particles will start floating. Okay, and these two are the special case for gas, because the gas will be more able to form this type of bubbles. Like liquid, there will be no chance to form a bubble. So here this will be the final state of fluidization, where the gas or liquid is able to lift up the particles that are far away from each other. So here drag is much more higher than the gravitational force of the solid. So from this you can tell me, like what can be the phase of contact between in the fluidization process. So what should be the correct answer? Can anyone let me know?
D is the correct answer.
Sorry.
D, gas liquid or gas solid.
uh,
Sorry.
yeah, gas solid and liquid solid, because you can see either we are using liquid and solid, that is liquid to lift up the solid, or we are using gas to lift up the solid. So D is the correct answer. Uh, Now this is the match the following. So we have blower. So blower is used to blow the gas or air. So it is kind of transportation of material. Okay, so for A it is 1. So this is the only option, but we can check for other equipments also. Now ball mill. So ball mill, it is used to reduce the size. So which is third option, B with 3. Rotating screen. Now as the meaning of screen itself, it says it is used for the separation of size. Okay, so for C it is 4. In centrifuge, it is used for separating solids, which is by settling and sedimentation. So D is the correct answer. Now decantation is an example of dash process. To answer this question, first we need to look into what decantation process is. So yeah, suppose you have a tank in which there are there is this liquid plus there are some amount of solids. Okay, and there are liquid 1 and liquid 2. Now if you allow, basically what we do, we try to give some amount of time, so that uh, here the liquids, the condition is liquids are immiscible in nature. So since they are immiscible, can anyone tell me what is the reason for immiscibility of any two liquids? Because this the reason for this immiscibility is the governing phenomena for the decantation to occur. So what is the reason for immiscibility? So different type of interaction between two liquid molecules that exist, and apart from that, immiscible liquids have different densities. Okay, so say for example, liquid 1 has low density. You can consider it here as oil. Liquid 2 is high density, which is water. Okay, so now if you allow, you must have seen at your homes also, if some by somehow oil and water are mixed, and if you allow some time, then the oil and water will get separated. So what is the reason for this is the difference in density. So if you give some time, so there will be two layers. Okay, this will be liquid 1. Because of lower density, it will be at upper layer. This will be liquid 2. So this is a kind of separation process which is commonly used in industries, where if there are two liquids and even if solid is present, then depending on the density difference or the density with respect to any of the liquids, if the solid has usually higher density, then it will settle down, or there are some type of liquid solids which has low density, say for example plastic, so it will float. Okay, so depending on the density, the layers will separate out. So this is a kind of separation process which is used in industry. Now another question is, conduction, which is a heat transfer process, involves dash. So what is the conduction? Conduction is a process. Suppose you have two blocks. Here it is T A, TB, okay, and TA is greater than TB. So as you know, at any particular temperature, the suppose these are the solids present in here, and like the molecules of the solids, okay, and here it is there also. Now in solids the molecules are very tightly arranged, or they are very close to each other, right? Now depending on temperature, both the type of molecules have some amount of energy, okay. Consider here that it has same material, so different temperature has different amount of energies with these molecules. So here in this case, as T1 is greater than TB, the energy with this molecule will be higher than energy with TB, block B molecules. Now if you allow this to contact, the vibrations, there will be more amount of vibrations in here, there will be lesser amount of vibrations in here. So all the particles in here, they try to vibrate, and they try to interact with each other. So as the temperature is higher, the collision will be more, and there will be transfer of the energy from one form, like one block to another, because here the energy in A and energy in B is more. So due to more collision, it will pass on the energy from here to here. So this passage also tries allows the heat to flow from this to this direction, which is from higher temperature to lower temperature. There will be one phase, one time where the entire block has same temperature, which will be equal to C, which is the equilibrium temperature. So the entire process occurs due to the collision of the solid particles or the solid molecules, which is due to the intrinsic energy of the molecules that depends on the temperature. So here the correct answer for this question is energy transfer occurs due to the collision of molecules, because like conduction is the phenomena in solids, so the fluid type of energy transfer is anyway eliminated here, and the photon, like energy transfer by photon of light, is the kind of radiation heat transfer which do not require any medium to for the transfer of energy. So the correct answer here is conduction, the energy transfer by molecular collision. Next question is, select the process generally practiced to separate two or more liquid components of liquid solution into pure fraction based on the boiling points of the component. So the correct answer here is the distillation, because in the distillation column what happens is, suppose you have two liquids L1 plus L2, and they have some different boiling points, okay. So the if you, in the distillation column there will be T1, T2, and here L1 has lower boiling point, okay, L2 has higher boiling point. So the one with higher boiling point, as you allow a temperature gradient, one with higher lower boiling point will tend to go upwards because it readily vaporizes, and L2, which has lower boiling point, it readily liquefies, okay. So here uh, there will be fractionation uh, in terms of vapors. So you will get pure L1 here, pure L2 here. And distillation is the most conventional process which is used in industries to get very pure form in the range of 99.9% also purity liquids in the columns. Apart from this, the other are easily eliminated because extraction is used when you have two liquids, obviously, but one of the liquid has more solubility in the third liquid, which is used to separate the other two liquids. So it is not at all related with the boiling point of the component. Absorption is totally a different phenomena, where you absorb from one phase to another phase, so there is no separation. Filtration is you need a barrier, and boiling of liquid is not incorporated, so filtration is also eliminated. Next question is, in the stripping process, a mass transfer occurs from which phase to which phase? So first we will look into the process. What is the stripping process? So usually stripping is in combination used with absorption. So first absorption occurs, then stripping occurs, okay, and stripping is again converted back to, like, this is a cycle that usually occurs. So what is it? So suppose you have, say for example, you all have heard of CO2 pollution, right? So we cannot allow CO2 to go into the atmosphere, so we want to separate, and CO2 is usually found with CO2 N2 mixture or CO2 CH4 mixture, any such mixture, okay. So N2 here is inert, suppose we have CO2 N2 mixture, so gas is allowed to pass in here, so we need to recover the CO2. So here there will be CO2 plus N2, and we allow some solvent, okay. Here the solvent usually uses amine solution. Since CO2 has a very high affinity for amine solution, CO2 will get absorbed, or it will react with a reversible reaction with amine to form a complex, okay. So now, like, the solvent comes in from here, okay, sorry, this is the wrong arrow, because we do not want to give external energy, so we allow to allow the liquid and gas to flow in its natural direction, like liquid in downward direction and gas in an upward direction. So as we move upward, there will be constantly transfer of gas, that is CO2 here, to the solvent, that is amine, okay. So here there will be CO2 rich, that is CO2 plus N2, for example it is 0.3 plus 0.7 mole fraction. Then here depending on purity we require, suppose it is 0.05 mole fraction plus 0.95 mole fraction. So the rest amount of CO2 is absorbed in the solvent, which is continuously occurring in the absorber. Now to make the process economical, we capture all the CO2. So for that, what we do, we allow the spent solution to pass in here in the stripper. Now here comes the main question. So in stripper, since the reaction is reversible, we allow the complex to break by increasing the temperature or so. So for that, since it is the liquid phase, it is a solution, so liquid to gas, we dissolve. So liquid to phase gas phase occurs by increasing the temperature. So amine plus CO2 gets converted into CO2 only, and it is obtained. So the type of mass transfer occurs is liquid phase to solid phase in a stripping column. So liquid phase to liquid phase to gas phase, sorry for that, liquid phase to gas phase is transferred. Now another question is, consider a chemical reaction A plus B gives to C, where we need to slow down the reaction. So how can we do that? We have three options. Use a semi-batch reactor for feeding B, keeping concentration low, slow mixing. So can anyone let me know how all the parameters are related with the rate of the reaction? So if not, I will proceed. Suppose this is the reactor which requires A plus B, like both A and B to give C. Okay. Now semi-batch reactor for feeding B, what does it mean? So we continuously add B and there is a pool of A, which means there is a continuous A and there is limited supply of B. Now the rate of any reaction is equals to, suppose it is a first order reaction with respect to both, then it will be KCACB. Now here Ca is constant, like it will change obviously, but Ca is there, like it is in bulk, so Ca will be high. But since you are supplying B in continuous mode and limited form, so Cb is limiting here and Cb decreases. Okay, so that is why the rate of reaction decreases. So this happens to be a right option. Another option is keeping the concentration low. Now if you take any reactant CaCb, now if you decrease any of the concentration, then obviously the rate of reaction will decrease. So the rate of reaction can also be reduced by keeping the concentration low. Another is slow mixing. Now mixing also plays a very important role in reaction to occur. Suppose you have very fast mixing. Okay, there will be more collision between A and B and there will be more reaction. There are more chances. Hello. Okay, so there are more chances for the reaction between A and B to occur, to form to give C. Okay, so higher the mixing, higher is the chances for reaction to occur with faster rate. So by slowing down the mixing, we can even reduce the reaction rate or we can slow down the reaction. So here all the options are correct and hence all of the above is the correct answer. Moving forward, this is the basic question, like what is the SI unit for temperature, which is obviously Kelvin. Next question is, which of the following method is or are the dimensional analysis method? So here by looking at the options, the Rayleigh method and Buckingham Pi method, these two are the methods used for the dimensional analysis. So that is the correct answer. Uh, so next is also a very basic question where you need to, which all are fundamental units. So time, mass and length all are fundamental units. So what other fundamental units are there, like apart from MLT, what other fundamental units are there? Can anyone list down? So the other fundamental units are for sorry, are for temperature, which is theta. Other are for current, which is in ampere. So those all are also fundamental units. Uh, yeah, candela is also one fundamental unit. Next is kinematic viscosity has the following dimension. So to calculate that, what is kinematic viscosity? It is nu, which is viscosity, which is dynamic viscosity, divided by density. The unit of this viscosity is kg per meter second, and unit of density is kg per meter cube, right? Now if we cancel the units, gets cancelled and meter cancels out with 1 meter. So what remains is meter square, like meter square and second raised to minus 1. So if we convert this into the dimensional form, it will be, for meter it is length, so L square, and for time it is t, like for second it is t, so t raised to minus 1. So the correct answer here is L square t minus 1. Next is Euler number. A dimensionless number is a ratio of the following. Like what should be the answer? So Euler number is has formula P by rho u square. So here P represents the pressure force, rho u square represents inertial force. So the correct answer here is pressure force by inertia force. Next question is, a low value of Froude number means that dash are large in comparison to dash. So for that, if we look into the formula of Froude number, so Froude number is u square, sorry, Froude number is u square by gd. Okay, so u square here signifies inertial force, and G represents the influence of gravity, that is the gravity force. So the ratio here is inertia force divide with respect to gravity force. So here it is asked that low value of Froude number. So for low value to occur, either inertia force is low or gravity force is high. So here gravity force needs to be higher as compared to inertia force. So the correct answer is D. Next question is, for an ideal fluid flow, Reynolds number is dash. So for ideal fluid, mu is almost equivalent to 0. Okay, so Reynolds number has formula rho v d by mu. So since mu tends to 0, here we can say that Re will tend to infinity. Next question is, which of the following is not a dimension? So here if we look into the options, length is a dimension corresponding to meter, time is a dimension corresponding to seconds, gram is itself a unit, it is not a dimension, and temperature is a dimension with for T. Okay, so the correct answer here is gram, which is not a dimension. Next question is, you can identify an invalid equation based on the dimensional homogeneity arguments. So this is a correct statement, because for dimensional homogeneity, suppose you have one equation, Re equals to rho Vd by mu. Okay, so since this is a dimensionless number, on the right hand side it is m0, l0, t0. Okay, so the right hand side also has to have m0, l0, t0 for dimensional homogeneity. Okay, now if we add v square, okay, like if we just do v square, then in that case, since Reynolds number is just a number, it will have as it is m0, l0, t0, but here the dimensions will be varied and it will not be equivalent. So the dimensional homogeneity is not maintained. So based on this, we can say that we can find out whether the equation is valid or not. So this is a very correct statement. Now the last question is, select the uses of dimensional analysis. Now if we look into the options, it allows rational formula for fluid flow, like flow phenomena can be derived. By dimensional analysis, the relationship between various physical quantities in an equation can be obtained, which is also correct. This is also correct and useful to find whether an equation of any flow phenomena is rational or not. This is also correct because these are the basic things which we do by dimensional analysis. So all the above options are correct here. So answer is D. So this is all from my side for today. If you have any doubt, you can tell me. If anyone has doubt, then they can unmute and let me know. Uh, so I guess there is no doubt and everything is clear from for you all. Yeah. So if you don't have any doubt, we can end this session. And thank you for your cooperation and answering all the correct questions. Thank you for attending. Now we can end the meeting and I will stop share. Yeah, Sandhya, you are saying something. What about assignment 2? Can you please unmute yourself and let me know? Sandhya, are you here? I guess she has left. So, uh, if you have any doubt, you can let me know in the next session also. So, thank you. I will end the meeting if you don't have any doubt. Thank you so much, everyone.